In this video, we're going to be thinking about current, voltage, and resistance in circuits so that we can define what those three terms mean and match them up with their units. Just a reminder that an electrical circuit has to consist of complete loops of wires with components that carry electrical power from a power source, a battery in this case, to the components and then back to the power source. This electrical circuit also has a switch as a controller. And we can compare an electrical circuit to a simple water system, with the electrical pump on a water system being similar to the battery on a circuit. The water would move through a valve, which would be a little bit like a switch controlling the flow of water. And there will be areas in the water system that slow down or use up the power in the water, like this bendy part of the pipe, which acts to resist the flow of water, just like a component uses up electrical energy and it acts as a resistance to the flow of electrical energy. And similarly, if there's a break in the pipe supplying water, water can't flow correctly around the circuit. And if there was a break in the electrical circuit because the conductors didn't touch and form a loop, then the electricity wouldn't flow either. So let's think about current. Current in electricity terms is the word used to describe the movement of charge in a circuit. And these charges carry the electrical energy from the power source to the components in the circuit through the conductors. Specifically, current is a measure of the amount of charge traveling through a specific part of the circuit per second. And this is similar to measuring how many liters of water flow through a pipe per second. Electrical current is measured using the unit amperes, or amps for short, and it's measured using an ammeter. The symbol for an ammeter is an A in a circle, and an ammeter device that we will use in class looks like this, with an A on the front. 1 amp of current is 1 coulomb of charge passing that point every second, and in equations, current is represented by a capital I, and the units are shown with a capital A, which is a little bit confusing, but current is represented by a capital I. Voltage. Voltage is known as potential difference. It represents the energy input or output of a circuit. And in circuits, power sources such as batteries will supply the electrical energy in the form of voltage, which gives the charges a push to flow as current. And this push comes from the difference between the energy they have on either side of the battery, very similar to the idea of having potential energy at the top of the slide, and at the bottom you would have no potential energy left. If we look at how to measure voltage, we measure it using a voltmeter. So it looks similar to an ammeter, but you'll notice there's a capital V on the front of the dial. The units for voltage is volts, capital V, and it's measured using this voltmeter, and the symbol for that would be a V in a circle on a circuit diagram. 1 volt of voltage means that every 1 coulomb of charge gains or loses a joule of energy between the 2 points. And in equations, we represent voltage with a capital V, which actually makes sense. Now, resistance is the third thing we need to think about. It's a measure of how much energy is used by components in a circuit. So it impedes the flow of the current. It stops or slows down or makes it harder for current to flow in a circuit. And energy has to be used to overcome this resistance. Components of a circuit with high resistance require more energy to be used for current to flow through them. And this would be like trying to run through water compared to running through air. It takes more energy to run through water than it would just running through the air, like as if you were running on grass. So resistance is measured using units called ohms, and they're represented by the Greek letter omega. It is not measured directly, but it is calculated using voltage and current. So we would need to understand how to calculate it. So we'd use an equation, and in an equation, resistance is represented by capital R. So in summary, electric current is when charges flow around a circuit. We use an ammeter to measure it, and it's measured in amperes or amps. Voltage, also called potential difference, is how big the push on the electrons is. We use a voltmeter to measure it, and it's measured in volts. Resistance is anything that resists or slows down current, and it is measured in ohms. And here is quite a helpful little diagram, little cartoon. So we have a pipe, and the amps, the current is the little green person trying to squeeze through because the resistance in red is trying to restrict the flow by putting a lasso around the pipe, but the voltage is giving the current a bit of a push, the voltage there in yellow.